Right, Matrix, in this lesson I'm going to be looking at finding the equation of the tangent to a circle at a given point. Okay, so for example, let me explain. When you've got a line that touches a circle at one point only, at say the points x1 and y1, that point is the point of tangency. Notice the word tangency. It's where the line T, the tangent, is a line that touches the circle at one point. And what happens is that if you've got the center and you join it to that point, you've got the radius, and the radius is perpendicular to the tangent. So if you remember, the gradient of the radius times the gradient of the tangent is -1. That's a property of perpendicular lines. Okay, and we can say the gradient of r multiplied by the gradient of t is -1. M of r times m of t, that's the symbol for gradient, as you know. Okay, so an example of this, let's have a look at this. Determine the equation of the tangent to the circle below if the center is given by this point, -1, 3, and the point of tangency, that's the point where the tangent touches the circle, is given by that point. Now have a look, there's your C, -1, 3, and there's your P, -2, 6. You'll notice that the point at which the tangent touches the circle is there, and we've got the center. Now what do we need to find if we want to find the equation of a tangent line? We're going to be using our traditional formula. Y minus y1 is mx minus x1. Remember, the x1 and the y1 is a point on the line, which happens to be that point. It's also meeting the circle there. You could, of course, also find the equation of the circle if you wanted to, but we want the equation of that tangent line there. We also need the gradient of this tangent. So to do that is quite simple. We can say, well, okay, what is the gradient of the radius? So we can say, if you remember the gradient of the radius, very simply put, what would that be? Well, we simply subtract the y's, so that you can go in any order you like. So you can say 6 minus 3 if you like. 6 minus 3 divided by -2 minus -1. Remember, what are you doing? With gradients, you say the y value of p minus the y value of c, 6 minus 3, the x of p minus the x of c, -2 minus -1. So it comes to 3 over -2 plus 1 is -1, and that, of course, is going to equal -3. Now, what do we know? We know that the gradient of the radius multiplied by the gradient of the tangent must be -1 because they're perpendicular. We know the gradient of the radius, so let's plug it into that little equation there. And if we divide both sides by -3, the gradient of the tangent is going to be 1 over 3 if you divide both sides by -3. Now notice, it's quite true. If the gradient of the radius is -3 over 1, look at that, if that's the gradient of the radius, the gradient of the tangent, you simply swap the sign around and make it from -2 plus, and 3 over 1 becomes 1 over 3, which is a third. And if you check, what is the -3 here multiplied by the 1/3 gives you -1. So if you've got the gradient of the radius, you can easily get the gradients of the tangent because they're perpendicular. So the gradient of the tangent is going to be 1 over 3. And we also have the x1 and the y1. So now to work out the equation is really simple. So let's write that down. We've got p as the point -2, 6 there. The gradient of the tangent is 1 over 3. That's your x1, your y1. So y minus y1 is m, x minus x1, and you plug in your values. Y minus the y1 is 6, the m is a third, x minus, careful now, it's x minus the -2 there. Careful, you're subtracting -2. So y minus 6 is 1/3, x plus 2, and y minus 6 is 1/3 x plus 2/3 if you distribute in, and a third times 2 is 2/3. So y would be 1/3 x plus the 2/3 plus 6, and if you work that out, 1/3 x, 2/3 plus 6 gives you 20/3. Simply use a calculator, and there's your equation of your tangent line. Okay, what a pleasure. Very easy to do, and you always get asked a question like that. So always remember, whenever you have a circle and you've got its center, whatever that center is, and you've got a tangent there and a radius, they're perpendicular, you work out step 1, the gradient of the radius, then you get the gradient of the tangent by the fact that these lines are perpendicular, and then you always use that point x1, y1, where the tangent meets the circle at that point, and it's a point on the circle.